Hello to everybody. In this session, we have to discuss some problems on divergence of the series. The first problem is discuss the divergence of the series. Summation an is equal to 1 plus 2 plus 3 up to plus n plus up to infinity. Solution for this problem. Here an is equal to n. An means nth term of the series. Here the sequence Sn is equal to a1 plus a2 plus a3 plus an. So that is Sn is equal to 1 plus 2 plus 3 up to plus n. Then Sn is equal to, so here we have 1 plus 2 plus 3 up to plus n. So nth term of this series is n into n plus 1 by 2. Then apply the limits on both sides as n tends to infinity. So we get limit of Sn as n tends to infinity is equal to limit of n into n plus 1 by 2 as n tends to infinity. So this is equal to, so when we apply the limit, so we get infinity. So that means the given sequence Sn is divergent, therefore the series summation an is also divergent. The second problem is discuss the divergence of the series summation an is equal to 1 cube plus 2 cube plus 3 cube plus up to n cube plus dot dot dot. So solution for this problem, an is equal to, so nth term of the series is n cube. Next Sn is equal to a1 plus a2 plus a3 up to plus an. So Sn is equal to 1 cube plus 2 cube plus 3 cube up to plus n cube. So the nth term of this sequence is n square into n plus 1 whole square divided by 4. So next we have to take limit on both sides as n tends to infinity. So we get limit of Sn as n tends to infinity is equal to limit of n square n plus 1 whole square by 4 as n tends to infinity. So apply the limit for this nth term, so we get infinity. That means the sequence Sn is divergent, therefore the series summation an is also divergent. Next, the third problem is discuss the divergence of the series summation an is equal to 1 square plus 2 square plus 3 square plus up to n square plus up to infinity. So the solution for this series is n is equal to, so the nth term of this series is n square, then Sn is equal to a1 plus a2 plus a3 plus up to plus an. So the sequence Sn is equal to 1 square plus 2 square plus 3 square up to plus n square. So the nth term of this sequence is Sn is equal to n into n plus 1 to n plus 1 by 6. So we have to apply limit for this nth term. So that is limit of Sn as n tends to infinity is equal to limit of n into n plus 1 to n plus 1 divided by 6 as n tends to infinity. So here apply the limit for nth term, so we get the limiting value is infinity. So that means the sequence Sn is divergent. So therefore the given series summation an is also divergent. The fourth problem is discuss the divergence of the series summation an is equal to -1, -2, -3 up to -n. Solution. So an is equal to, here the nth term is -n. Next the Sn is equal to, so a1 plus a2 plus a3 up to an. So Sn is equal to, so the what is given sequence is -1, -2, -3 up to -n. So nth term of the sequence is -n by 2. So in next step we have to apply the limit for this nth term. So we get limit of Sn as n tends to infinity is equal to limit of n into n plus 1 by 2 as n tends to infinity, that is equal to, so here apply the limit, then we get minus infinity. So that means the sequence Sn is diverges to minus infinity. So finally here the given series summation an is also divergent. And the fifth problem is discuss the divergence of the series. So summation an is equal to 1 plus 1 plus 1 up to plus minus 1 raised to 2n plus. Solution. So here nth term is an is equal to minus 1 raised to 2n. So what is Sn? Sn is a1 plus a2 plus a3 up to an. So Sn is equal to 1 plus 1 plus 1 up to n terms. So that means 1 plus 1 plus up to n terms means Sn is equal to n. So take limit on both sides. So we get limit of Sn as n tends to infinity is equal to limit of n as n tends to infinity. So when we apply the limit, then we get the limiting value is infinity. So that means the sequence Sn is divergent. Then the given series summation an is also divergent. And the sixth problem is discuss the divergence of the series summation an is equal to -1, -2, -3 up to -1 raised to 2n minus 1. Here an is equal to nth term of the given series, that is -1 raised to 2n minus 1. Next step, so what is Sn? Sn is a1 plus a2 plus a3 up to plus an. So an Sn is equal to, so -1 -1 -1 up to -1 n terms. So Sn is equal to, the nth term of this sequence is -n. Then apply the limit on both sides as n tends to infinity. So we get what? The limiting value is minus infinity. That means the given the sequence Sn is divergent. So finally the given series summation an is also divergent. So revision of this session is, here we have to discuss on problems of divergence of the series. So these are the reference books to refer this session. So thank you to everybody. Thank you very much.